So we are on the front side where we are going to be continuing on lesson 3.3 today. And our two learning goals: evaluating a function for given input values, finding a reasonable domain and range for the function. We're going to practice some of each of those, and then you'll be on your way working, okay? So on page 181, we are at the check it out problem at the bottom of the page. Everybody's book should be open to page 181. We are going to be evaluating functions. So example 4 will also give you some more help for learning how to do this. We will practice the check it out problems together. So let's look at 4a. I've already written it down for us. H of c equals 2c minus 1. We are to evaluate that for the given input value c equals 1 and for c equals -3. What's our function's name? It's function what? Think back to yesterday. It's function what?
HC.
No. It's part of that. It's function h. The function h. What is the independent variable? C. C is our independent variable. It's our input value. It is like our what? It's like our x, yeah. So the c's would make up the domain in this case rather than the x's would, because c is the independent variable, c is the input variable in this one. So we have function h, where c is the independent variable. What is the function rule in 4a? What's the function rule in 4a? Ooh, this was just yesterday, folks. Algebraic expression set equal to the dependent variable. Well, maybe we should identify the dependent variable. Okay, Cassie, what have you got for me? The function rule or the dependent variable?
Function.
Okay, what's the function rule?
2c minus 1.
Yeah, no, just stop right there. It's just an algebraic expression. 2c minus 1. Take the c value times 2 and subtract 1. That's our function rule. And what is the dependent variable?
-1.
No. No. H of c. H of c. Just like f of x is the same as y, and y is the dependent variable. H of c is the same as y, it's the dependent variable. So the dependent variable h of c is equal to taking the independent variable c times 2 and subtracting 1. So when we do this, here's how we show it. We're supposed to do it for c equals 1, so we'll do that one first. H of 1, that is saying, take the function h and evaluate it for input value 1, for the independent variable being 1. So then we go over to the function rule and say, okay, we're supposed to input 1 in for c. Our output, h of 1, our dependent variable, h of 1, is equal to 2 times 1 is 1. And then we're going to take 1 away from that. So our h of 1, our dependent variable, is, what's 2 minus 1?
1.
1. So what would the ordered pair be for this function that we just found? Paul?
I didn't.
Oh, I thought you were raising your hand, sorry. Jalen?
1.
1, 1. The input value, the c value is 1. The output value, the h of c is 1. Ordered pair 1, 1. That's one of the ordered pairs for this function. But they didn't want us only to find 1, they just happened to want us to find a couple of them. So there's our second one. So now we're going to find h of -3. So in other words, evaluate the function for input value -3. So substitute -3 into the function rule for the c value and evaluate. So what's 2 times -3, first of all? -6. We multiply before we subtract, and then we can subtract. Now, h of -3 is -7. If you need to change this to add the opposite so you can do it, then do that. -6 plus -1, that's -7. What order of pair do we have now? Be careful, what did we just find? -3, -7. We just found the output value when the input value is -3. So the input value is the x value, the first coordinate of the ordered pair. The output value is the y value, or the second coordinate of the ordered pair. So we had an input value of -3. The output was -7. So questions? This is the kind of work you need to show in your homework when it tells you to evaluate. Okay, let's go on to the next one then, 4b. What's our function's name? G. What's the independent variable? T. What's the function rule? 1/4 t plus 1. What's the dependent variable? G of t, yeah. So we are supposed to, first of all, we're supposed to do it when t is equal to -24. So we're going to find function g evaluated with the input value of -24. By the way, that does not become -24g. Do not mistake that, as there's algebra going on over there. That is a notation saying we have function g that we are going to evaluate for input value -24. So we're going to put -24 in for the input variable and evaluate. So g of -24 is equal to, what's a fourth of -24?
6.
And what's a positive times a negative? Negative, so this would be a -6, wouldn't it? And -6 plus 1? -5. What ordered pair do we have? -24, -5. We just got an output of -5 for -24. Input value. Okay, you do the other one. We have to do it for input value 400. Do that one. And write the ordered pair that you just found for this function. So what ordered pair did we just determine for function g? Paul?
100
Okay.
and 101.
Ordered pair 400, 101. Input 400, output 101. Okay, so evaluating functions. Any questions? Okay, again, there's examples in the book also to help you out with that if you're having trouble when you're not in here. Okay, our other learning goal is finding reasonable domain and range of a function. You need to turn your page to 182 and approximately the middle of the page. We're going to do check it out problem number 5. So read that problem and first of all decide what would the independent variable be and what would the dependent variable be. So read it in your books, not up on the board. Did they pick any variables for us in this situation? No? Okay. So let's use x and y, the generic one, okay? So x is which variable, the independent or the dependent? Independent, okay, so let's start with the independent variable. What is, so we're going to describe, x is, so what is our independent variable in this situation? Jaden?
Setting on the space heater.
Okay, the what?
Setting on the space heater.
Okay, so can we call it setting number? Are they numbers? Or are they like off, low, medium, high? What are they? They're numbers? Okay. Setting number. Y is our dependent variable. In other words, x is in control. What's the result of x's control? What, Bryn? Number of watts. Yeah. Well, how many watts is that heater operating at down that setting? That's the first thing we do. Now we decide how can we use that independent and that dependent variable in an equation. So we really basically have to figure out a function rule, don't we? So what's our function rule in this situation? What do you think the function rule is? What will we have to do to x, the independent variable, to get the y, the dependent variable? What will we have to do? Emma? 500 times what? Okay, so 500 times the x, so 500x would give you the what? What do you think, class? Would that work? If you take the setting number times 500, it should tell you how many watts the heater is operating at. Okay, so there's our function. And did they tell us to write it in function notation, by the way? Did it say anything about writing it in function notation? No? Okay, then we don't have to. We have to find the domain, a reasonable domain and range, don't we? Isn't that what we're instructed to do? Okay, so we need a domain. Well, I think we can figure that out right now. What's a reasonable domain for this situation? In other words, what makes sense to put in for input values for x? Setting numbers, what are they? What are the possible setting numbers on this heater? 0 to 3. In halves, quarters, whole numbers. So our domain is made up of the following 4 x values. Well, then that means our range is going to be the outputs of those. So we're going to show our work here. We have to find out what f of 0 is. And I know this one might be easy to do in our head, but we're going to show this. We're going to evaluate the function we wrote for the given inputs we put in our domain. So the output when x is 0 is what? 0. Doesn't that make sense? Heater's off at 0, no wattage being used. So we have ordered pair what here? 0, 0. We just found our first member of the range, did we not? Okay, f of 1. The function evaluated at 1 is 500. Ordered pair what? 1, 500. We just found our second member of the range. And I think I might have some people in here not doing this right now, and so they're not going to get this size counted as okay either, because they're got another agenda going on, so you'll be doing it on your own. So now we're evaluating it for f of 2, and setting is at 2, so what is the wattage then? 1,000. We just found ordered pair
2,000.
to 1,000. When the setting is at 2, the wattage is 1,000. We just found our third member of the range. And our last one F of 3. When the setting on the heater is at 3, the wattage is 1,500. Ordered pair,
3 and
3, 1,500, 1,500. And so we just found our last member of the range. Lots of you are getting papers back that because part of what you're doing, not doing is writing set notation. Remember how picky I said I'd be? Are there any other members we've left out for our domain range? Okay, these are what we call the reasonable ones. It makes no sense to have an input value of 4 because what? The heater doesn't have a setting of 4. So there's no reason to put that in our domain, no reason to get an output value for it. Okay, questions? Okay, then I'm going to stop the recording here.